And welcome back, and it is the 5-a-day further maths for the 17th of March, and let's just jump straight into the first question. Right, what do we have here? The lines A, B and CD bisect. Okay, so without reading any more in the question, the word bisect is important here because it means I've got midpoints. Each other at M, which is the midpoint. Calculate the coordinates of C. Right, okay, so quick thing. So my method here is I'm going to use A and B to calculate M, because it's at the midpoint. Then I'm going to find out how to get from D to M, and I'm going to repeat that to get from M to C. Let's do that step by step. So my midpoint is the midpoint of AB, which is going to be 1 plus 13 over 2, average of the x values, and minus 8 plus 2 over 2, average of the y values, which is going to be equal to 7 over minus 6 over 2, which is minus 3. Okay, so I've got my midpoint. Then what I need to do is I need to work out how I'm going to get from D to M. So the vector D to M is equal to, well, I'm going from 16 to 7, which is minus 9. And I'm going from minus 7 to minus 3, which is plus 4. And that is also equal to the vector to get from M to C. So what I can do is I can take my M value, which is my coordinate of M, which is the thing I've just worked out. I can add on the vector here to get me to C. And that's going to give me that C is equal to, well, 7 minus 9 is minus 2, and minus 3 plus 4 is going to give me 1. So the answer to my question is C is equal to minus 2, 1. That's a clever, good question. I like that question. Well done. Okay, very clear. It tells me what to do. Using completing the square, write down. So there's a lot of maths words here. So write down means it should be pretty easy, not a lot of maths going on. The coordinates of the minimum point of the curve. Okay, this is just your pretty straightforward. Complete the square and interpret. So half minus 8 is minus 4. Minus 4 squared is minus 16. Minus 11, and that's going to give me x minus 4 all squared minus 27. Which means my turning point occurs when this bracket equals 0, in other words 4, and when this equals 0, the only thing that's left is minus 27, so therefore that is my minimum point, 4 minus 27. Next question. Find the range of values of x that satisfies both. It's not a trap, but there's definitely part of this that's very easy to get wrong. So let's start with the easier bit. If 3x divided by 2 is greater than minus 10, that means x is greater than minus 20 over 3. So my first critical value is going to be minus 20 over 3. I'm going to need that in a second. This bit I'm going to think of as x squared minus 3. And the reason for that is I can write it as x minus 3, x plus 3 is greater than 0. And this is the, again, trap is not the right word, but this is the thing you can get wrong. This is actually a quadratic inequality, not just a straight square root both sides. So the values I need, quick sketch over here, so the values I need are all values greater than root 3 or less than minus root 3. So my critical values are root 3, minus root 3, and minus 20 over 3. So let's write those down. So I've got minus 20 over 3 is the smallest, then minus root 3, and then I've got root 3. And I want all values that are greater than root 3, so I want all these values here, or less than minus root 3, so all these values here, circle. And I want all values that are greater than minus 20 over 3, so in other words, all these values here, and I'm looking for where they intersect. So in other words, I have two arrows or two lines between these points here. So my answer, finally, is going to be all the values between minus 20 over 3x minus root 3 and x is greater than root 3. And to be clear, that word there is or, because you can't be both greater than root 3 and less than minus root 3 at the same time. We got there. Wow, what a question. Final question. A curve has equation. Work out the equation, the normal. So we're back to differentiating again, aren't we? So let's just do that straight away. I've got dy dx is equal to, well, 5 over 2 times 2 is 5. So that's going to be 5x plus 12. And I'm doing it at the point x equals a half. So at x equals minus a half, the gradient m is equal to minus 5 over 2 plus 12. And minus 5 over 2 plus 12 is going to be, well, 12 is 24, 24 minus 5 is 19. So it's going to be equals 19 over 2. That's such a weird value. Let me just Yeah, no, I'm happy with that. That seems okay. Which means my normal, what am I doing? Work out the gradient of the normal. So my normal gradient, so m perpendicular, is going to be the negative reciprocal, which is minus 2 over 19. Not nice at all. And what am I doing? I'm working out now. I would normally say do whichever method you want. And I still mean do whatever method you want, but I think it is much, much easier to use the y minus y1 equals mx minus x1 method. So I'm going to use this with this gradient and this coordinate. Let's get rid of that there so it's not in the way. With this coordinate, so that's going to give me y minus 5.375 is equal to m, which is minus 2/19, x minus plus 0.5. Oh, horrible. Then I'm going to multiply everything by 19, which gives me 19y plus, calculator again, so 5.375 times 19 tells me it's 817 over 8, that's important, is equal to minus 2x minus 1. Then I'm going to multiply everything by 8, so 19 times 8 is equal to 152. Y plus 817 equals minus 16x minus 8. Now, why have I done that? The reason I've done that is because it tells me here that this needs to be in this format here where these are integers. And I've now made them all into integers, which means I can collect everything to the appropriate side. So 16x on the left-hand side plus 152y plus, well, 817 plus 8 is going to be 825. That is equal to 0. Correct format, question done. Wow, what a couple of questions today. Good mix of questions today. Definitely pretty challenging today. So as ever, let me know how you've done. Do like and subscribe, and I'll see you for the next one. Thanks all.